All right, good evening, everybody. I need to get these slides shared to you all. Welcome to the Python across Alberta. We don't really have a name. I think I've heard PyBerta thrown around on our screen here. I have links to uh, two Calgary groups. One is called PyYYC Data. So while they don't just limit themselves to Python, you'll be hearing a lot of Python if you do hang out with PyYYC Data. So they have a website. Please check them out. We also have PyYYC, so the Python meetup in Calgary. They have videos going back quite far on their website, and their website also includes a link to their YouTube channel as well. In their YouTube channel, it actually since we went virtual, we've kind of shared the videos. I believe that the Calgary meetup, the Calgary team has done us a solid favor, us Edmontonian organizers, a solid favor by uploading the videos afterwards. So really have to thank the organizers for doing that on behalf of us. And of course, for the Edmonton chapter, I should. We were just talking about how the website's not accessible right now. I do apologize. Um, Temporary with an asterisk. I hope to get it back up soon. Our Twitter is also fairly dormant, but what isn't dormant is our Slack. So we are part of the larger Dev Edmonton Society Slack workspace. So if you are not part of it already, please join. You'll be joining. I think there's probably a couple thousand of us now in that Slack workspace, and it's not just developers. It's basically if you are involved with technology in some way in your professional capacity, or you're a hobbyist, or you're curious about the world of software. I invite you to join our Dev Edmonton Slack. And of course, within our YouTube, the Dev Edmonton YouTube, we have a playlist of the EdmontonPy videos. Most of them were back when they were being done in person. I think there are a couple virtual ones, but I would still recommend maybe taking a look at PyYYC. Okay. Although we're meeting virtually, I still wanted to thank Edmonton Unlimited, who have licensed Remo for us over the years. And if you're unfamiliar with Edmonton Unlimited, that's kind of where I was as well about 2 weeks ago. They are formerly known as a couple umbrellas. I think not just Startup Edmonton, but if I just mention the name Startup Edmonton, that probably resonates with more of us here. And so I believe they combine three different similar slash overlapping, um, I guess, agencies or nonprofits, and combine them into Edmonton Unlimited. So I want to thank them once again for licensing Remo for all of us. All right, on to remote jobs. So for the remote jobs, I used to have speaker notes for this, but that's okay. With Muckrack, they are a PR communications platform. So they basically host um, all of their infrastructure on the cloud. And so they're looking for a senior backend engineer with not only Python experience, but with Django experience as well. I took a look at their job posting. They are hiring mostly for Python, but they'd also like a little bit of front end skills there if you have it. With CodeCov, I think they have an ongoing internship job posting. So the fact that they have one means that they probably have some kind of a more formal internship program. So that has, I guess, from my own experience, any sort of formal internship programs usually means the company is taking it fairly seriously. Um, and CodeCov is also looking for a senior software engineer. They are a DevOps platform that a lot of developers use CodeCov to. The simplest thing they were made famous for basically reporting your code coverage. How many percent of your entire code base is covered by your entire test suite, or your test suite, I suppose. Um, yeah, I believe they're looking for Python skills. I think you'll have to read the job posting to get more specifics on that. And of course, because now we're in a remote slash hybrid world, there's three websites I wanted to mention as well, that are all should be, with asterisk, should be remote friendly job positions. And of course, please check out the opportunities channel in our Dev Edmonton Slack if you're either looking for a job or you're looking to hire great people. So this month is October, and usually in October, there's a big event called Hacktoberfest. And in the past, in the before times, I like to call it, we used to, have like these in-person socials and all these kinds of things. So while we're still, figuring out, um, how we work with Edmonton Unlimited and all these sorts of things, there's a lot of change going on. So um, I wanted to maybe take a bit of more of a low key sort of announcement of Hacktoberfest. It's still going on. Don't know if there's going to be any in person things, happening in Edmonton this year, but that's okay. I've provided a couple links here, not only for people who have never participated in Hacktoberfest before, but also for people who have never contributed to open source. I love Hacktoberfest because the website is very thorough. It gets better every year with the instructions for how to get started. I think that it's extremely beginner friendly. And my second link is maybe a little bit of a cheat code, because if you want to get your feet wet and not want to take on solving the toughest world problems right away, don't worry. There are, I guess, ways that you can contribute as a beginner by looking at a couple repositories like the one I've listed. For those who have participated in Hacktoberfest before, the thing that is new is that GitLab repositories are now in the mix, which I think is super good. I think that'll probably open up a lot of other repositories and other projects that were not necessarily part of Hacktoberfest in the past. And last but definitely not least, I think for me, getting that sick T-shirt when you reach I think the goal is, in the past it was 5 pull requests, but do check the participation link to see if that has changed. This year, if you don't want to get a T-shirt and you're thinking about our planet, you can instead put your name down, and DigitalOcean and the sponsors will essentially plant a tree in your honor. So that's Hacktoberfest. It's a great way to not only contribute to the open source community, but also learn and improve your skills in terms of collaborating with other colleagues, especially within an open source context. And not to lay it on too thick, but I will say personally that participating in Hacktoberfest and just deliberately being an outsider contributing to another person's project causes me to improve on the ways that I interact with my colleagues at work and the way that I communicate at work as well. So there's that. All right, moving on. Oh, I have speaker notes for this one. Okay, so Python 3.10.7. I do regret that we were unable to meet in September. However, 3.10.7 is a fairly important version bump for Python 3.10. It includes a fix for a CVE, and this one's pretty serious because it can be a potential denial of service when all Python is doing is converting between integers and strings. So when you're doing I don't want to summarize incorrectly, but basically I believe it's sort of like casting in between, and they had to patch in, they had to fix a bug. Otherwise, an abuser could, if they knew your infrastructure was running on Python, essentially take your servers down by converting instance strings. That sounds pretty serious. So I highly recommend that if you're using Python 3.10, or basically even if you're using Python 3.x, take a look at the blog post there and upgrade as soon as you can. Also, PyCon US, it happened in person, and they were gracious enough to provide the videos on demand on YouTube, just like us and PyYYC. But they have like a lot of content, and I believe they've also made most of it free to consume, which I think is wonderful. So do take a look at PyCon US 2022's videos when you can. And the last one was a tutorial that caught my eye from PyCon 2022. Sadly, it's also the only tutorial video on demand that ended up being decent quality for PyCon. Essentially, they hired like an AV company, and the recordings were really bad for most of the tutorial sessions. But one survived, and I thought it was a really good one because I need to learn this skill myself. Playwright is a modern browser automation testing tool. It's open sourced. It was originally built by Microsoft. However, you may, well, some people, including myself, may hold our nose talking about Microsoft, but genuinely, there are good people there, and Playwright has, to me, seems to be kind of the new Selenium, so to speak. I could be wrong on that, but that totally means I need to brush up on my skills. So what I will do is I'll take a look and jump around this PyCon video. It's over 3 hours long. I think that these types of tutorials are great for beginners, but for the more intermediate and experienced folk, you can also jump around um, and yeah, see what content you can glean from that Playwright tutorial. All right, on to what we all came here for. So for our main presentations, we have two. I believe the speakers have told me they're on the smaller side. They may even talk for less time than I talk, which is totally fine. The first one will be from Kaitlyn, titled A Cool Python Project. And then the second presentation will be Shuffling in Python by Abram. What I will ask the audience to do is basically post your questions in Remo. You can do that in the chat. You can also do it for the observant audience. There's also a Q&A tab in your virtual auditorium. I know to check both, and I basically ask that you post your questions, but I will get the presenters to answer them at the end of their presentation. Okay, with all that said, I'd like to see if I'd like to open the floor up for Kaitlyn to start.
Hello. Okay. Oof. Let me move this. Hi. So I guess I'll start this off with an introduction. My name is Kaitlyn. I am a recent graduate from Algonquin College's computer programming diploma program. I'm originally from the good old United States, but I've been in the Sherwood Park area for a little over a year now. I am a community manager for a Discord community called the Femmes and Thems in Tech, where we are a global community for women and non-binary folk in tech to just gather and network and all sorts of cool things. And I'm excited to say that next week I start a new position as a DevOps engineer. So finally have a little job that I can attach to my introduction. With all that aside, I'm really excited today to go over this little project that I've done called Pair. So essentially, my little PowerPoint is set up in 4 sections. We've got what Pair is, why I chose to create Pair, how to configure Pair, how to start Pair, and then the demo and the source code. So Pair is a Discord bot written in Python. I believe it was like the lower end of the 3.10 that I started. However, I did upgrade to 3.10.7, and she's running just fine. So that's good, and it uses the Discord.py API, I believe version 1.6.0. Pair is a small scale, very monolithic solution to an automation need that I had in the community, the Discord community that I run. I don't know how many of you use the random coffee channel in our Dev Edmonton Slack, but the bot was inspired by that. I figured, well, hey, what better way to get people to connect with each other than to just create something similar and pair people up every week or every other week so they can kind of get together and meet and network without having to break that ice. I do that for them. So it was inspired by that Slack random coffee bot. However, it works entirely in the client. The random coffee bot, you have to click on a web page and opt in on the web page, and then it runs weekly. However, this bot is entirely in the client, done using Reaction, the Reaction system. It's my first ever Python project, and I absolutely love it. It's like having your first car, even if it's old and clunky or a 3-cylinder like mine. You just love it anyways. So I'm very excited about this, and yeah, I would definitely consider it more of a like small scale MVP, and has lots of room to grow. So yeah, speaking of scale and scope, for the scope of pair, I chose to focus on tagging or pinging the pairs of users, pairing them using line breaks, which you'll see up here in a demo. The configuration, which will also be shown, and reaction deletion and fetching and shuffling a user list. I'm using the API commands, and then out of scope is just ensuring pairs are unique weekly, which I'd love to work on in the future, maybe next iteration, who knows. Editing those messages that will be created, and hosting online. I don't know if people are familiar with Discord. The Discord is very similar to Slack in a lot of ways. It's a little bit more aimed towards the gaming community, and a little less professional than Slack is. However, it has a very similar setup. And when you have bots, you typically would host them online, so multiple people could use that one bot user. For this, that was just out of scope and unnecessary. So that leads us to why I wrote pair. So essentially, I created this coffee chat system where I would tell the people in my community, hey, click on a reaction and I will pair you up manually every single week with somebody new. And then like 80 people reacted, and I was like, wow, I cannot do this. I do not have time to sit there and do it every week. So I was doing research on what solutions existed for Discord, and unfortunately, there wasn't something that met my needs exactly, which was a good thing. It gave me an opportunity to learn Python while doing something that I love. And then also here, I had a school project in my final semester for one of the classes that I was in. And since my school was very Java based, we learned all our object oriented programming fundamentals in Java. They wanted us to do something non Java related. So I knew Python would be my first go to. Like, not writing public static void, it just sounded so delightful for me. So I was very, very excited to move into Python. So yeah, how pair works in a nutshell before I show you. So like I had said before, a Discord bot typically would be hosted online if you wanted many people to use it. I chose to opt out of that because, one, it's not written in the most scalable manner. Two, I really didn't want to pay for hosting it and managing maintenance on that. So I chose to upload it in a GitHub repository and just let anybody play with it however they want. So what you would have to do if you were to use pair or to use any Discord bot in this manner is you'd have to create your own Discord bot using the Discord developer portal. Then, of course, you'd have to set up your coding environment and clone that repository from where it stands now, at least, and install the libraries that the bot depends on. For this one, like it said, 3.10. I did update the 3.10.7, and it's working. And the 1.6.0 Discord.py, I tried upgrading to 2.0, and I would have to do a little bit of fixing to make that work. So if you were to work with pair, definitely use 1.6.0. And then I also used Python .env to hold sensitive values, and then pandas, which is a library that you can import to use with like library management or writing to and from CSV files and whatnot. There's two commands. There's only two commands for the spot. There's a create command and a pair, both prefixed with the exclamation point. And yeah, I guess from here, I get to show you how it works. So let me minimize this. So really quick, I'll run over these tabs that I have open. I guess we can hide that. This is just the documentation for discord.py. It's modern Pythonic API using the async await syntax. There's lots of different methods and different neat, fun things you can do with discord.py. So I definitely recommend taking a look at the API documentation if you want to learn more about it. I use .env, which has the key value pairs to set up those environmental variables, pandas. I'm sure many of you have used some of these before. So I guess here, what I'm going to do really quick is I'm going to share this here in case anyone wants to look at it while I'm going over this. First things first, I'm going to do a little demo as to how it works. So this is what Discord looks like. As you see, there's like channels to the left here. Very similar to Slack. Obviously, the server is very small, so there's only one channel. And yeah, so if you were to begin using the bot, first you would have to set it up and run it. I just have it running in the background in my integrated development environment. And you would issue the command that I had listed. So when that command is issued, it starts a configuration loop. I chose this because initially I had, people doing parameters, title, description, but obviously that became too lengthy and it was just too prone to errors. So I scrapped all that and chose to create a configuration loop. So you would create the title. So a host message would be the message that collects the reactions for your pairing. Now, mind you, I created this bot for coffee chats, for networking purposes, but I wrote it so it could be used for anything. So for the sake of this demonstration, let's say we want to play chess. We want to pair people up to play chess. So we would title this opt in to play chess. And then it would ask for a description, which would be the small text in the embed. So click on the check mark to opt into the pairings. All right, so now it's going to ask us what reaction we want to use. I am going to choose check mark because that said check mark. So I did it this way because if you want to do any of the reactions, there's so many reactions that are available, you can pick it and customize it to what you would like it to do. So that is all for the host message, the message to collect the reactions. So now we're working on the pair message that posts when we issue the pair command. So let's say this week's chess matchups are, so this will be our title for the pair message. The description will maybe say, I don't know, I don't want to type something to say yada, yada, follow the rules, have fun. You get the gist of it. All right. So after you type in the last configuration, it's going to auto delete everything except the create command and in hindsight, I kind of wish I had to delete that as well. But it's going to delete everything to kind of condense all the junk that's created in this configuration process. And it's going to automatically add that reaction so users don't have to go looking for it. So I'm going to click on the reaction because I want to play chess. And yeah, so let's say at this very moment, I try to pair. It's going to say no pairings available because you can't play chess by yourself. Yes, there's 2 reactions, but the bot, it's its own. You can't play chess against the bot. That doesn't count. So what I'm going to do, I'm going to cheat a little bit to show you how this is supposed to work. We're going to steal the reactions from this. I'm going to go into my CSV that, oops, I need to copy the ID, not the link. I think I also need to copy. I'm going to save that. That's totally cheating, by the way, but for demonstration purposes. So now when I do pair, it's going to pair the users that have clicked on it. It's going to pair them in groups of 2. The way I have the bot set up is groups of 2, and then there'll be groups of 3. How you play chess with 3 people, I don't know. Maybe you do 2 and then the tiebreaker. Those are issues to be dealt with beyond the scope. But yeah, so if it's an uneven amount of reactions, it's going to do all groups of 2 and then 1 group of 3. If it's uneven, or if it is even, it's just going to do them in groups of 2. So yeah, that's exactly how pair works. It was a really nice solution for what we have here. This is more pair in action in my server. This is how I use it to pair people up without me having to do it manually. And it's actually very nice. And yeah, it's been really, really helpful. I'll quickly go over some key points on this code here before wrapping things up. So yes, originally I had this as bot.py and bot underscore functions.py and then the test file. However, I found my functions file was way too long, like way too long. Now, mind you, it's my first Python project, so not everything is written like in the most optimal manner. Like there's some things I just recently converted to like ternary expressions and whatnot to kind of condense some of the code. But like the main file here is you're going to import your libraries and your other files, your values from your .env. This right here is going to create the Discord intent and the context object. These annotations right here, this is going to say that this right here is the command. So an exclamation point create in the Python in the Discord, I mean, is because the command was actually named create and it has this annotation. The reason why there's a permissions check here is to ensure that only an admin, and I chose band members because, you know, some lower level moderations typically don't have this role and you wouldn't want them to be able to do this. In a later scope, maybe there'd be a way to make that even customizable, but imagine allowing the entire server to pair people all the time. That would be pretty bad. So yep, this right here is just going to save these answers. It's a little bit jumbled, but we're enumerating through the prompts. We are fetching messages. We also have I'm trying to find it. Oh yeah. We have an automatic reaction deletion because sometimes people click on those reactions and then they leave the server, they leave the guild, and that can be problematic. So it will actually check for users that are not in the server before it pairs, and then it'll remove their reaction before running the pair, and then it'll add it to the user list. And right now it just shuffles. I've spoken with several people trying to figure out, okay, hey, how can I like add some sort of, I don't know, database or any sort of like storage system to save pairs and stuff. But it's definitely a lot more complicated than I thought because of the fact that it's not the same amount of people and there's people coming in and out. So hopefully one day I can brainstorm that coming up here to keep the pairs unique. We have, these are just our config. These are the prompts. They're just hard coded in here because they can be. I guess you could optimize it a little bit here, but why not? It's gonna config through here, loop through here. And then I just use, this is actually Python 3.10 is the match case. And see, as a Java person, like I was like, what do you mean Python doesn't have a switch case? So when they added a match case, and I was very happy. They use this file right here, the CSV controller, just exports and imports data to the CSV here that we've named root message. This just saves the message ID in the fields, so Discord knows which message to fetch the reactions from. This is the logic that I have here in our pair embed for creating the list. Right now, it's only separated via line breaks. There's not really a whole lot of complication to it. And in using those emojis to kind of separate them on the list itself. And then this is that like error validation or checking to ensure that more than two actual users or two or more actual users are present on a list before creating that pair. So yeah, and then you saw me cheat earlier. This is obviously not the ID for the rest of this message, but this would save the actual message here. I guess it'd be nice if I wrapped it, but that works. And then yeah, that pretty much concludes all of it. All of the code. As you see, I had to do a lot of documentation writing for this project, which is why also it was a small scale or small scope. My professor told me to not boil the ocean, and I very much wanted to ensure I did not try to boil the ocean. So yeah, let me go ahead and minimize this. We'll come back to this. And yeah, with that, I mean, that pretty much concludes pair, the first iteration of pair. I'm really excited to see what it has done for my little community that I run. I'm excited to see where I move forward with it. And yeah, definitely open for suggestions, for help, for any sort of feedback. And now I get to go back and look at your questions. I've been talking all this time and I don't even know what's going on. Okay, there's only one question. Is there any other questions? Let me stop sharing.
Well, I think typically the questions will flow in as I start talking. So yeah, typically just sort of as people are presenting, sort of come up with questions as they're presenting. But before I go into it, I just wanted to repeat. I think I saw a couple applauses already, but I do want to say, want everyone to give a round of applause for Kaitlyn. I think that when I had asked Kaitlyn to create 4 slides, I was literally expecting like a white background with some of that, Comic Sans going on. So this was above and beyond.
I can't do that.
So that was great. Again, thank you, Kaitlyn. And so I'll go into the question. I noticed that as you were talking about things when you were typing in that Discord message bar, and you said, you know what, I thought about putting in title, I thought about putting in description. You know what I said? Never mind. I was wondering if, while you were testing pair, did you stumble upon any edge cases? And if so, were there ones that you solved, and were there ones that you just said, you know what, like, we're just not going to bother with it for now?
Oh, definitely. And I feel like when I made that comment about boiling the ocean, I really did want to like come out with like the biggest and bravest project. Yeah. But when you're doing that alongside of 4 other projects, you kind of have to like make cuts there. Let's see. Yeah, I would say I stumbled with the mentioning. I stumbled really hard, and I still have this stumble with testing, like automated testing.
Oh, sorry. Yeah, I didn't. So, wow. Okay. I guess when I usually speak with someone who presents themselves as a beginner, I assume that they walk into our world with testing as manual testing, but you
I
assume
did
that
I did a lot of manual
okay,
testing.
so
That's why I have
I'm
that
not
server.
crazy. Okay, so when I
No, I
meant
did some automation testing, but if you go like I have test.py in there, and a lot of it is like assert not none. It's like, well, it exists. Does it exist, right? I don't know, but it exists. But it, the hardest thing about writing unit tests for this bot was creating that pseudo context object, and I still haven't completely figured it out. I've seen a few GitHub links on how to completely and accurately mimic a Discord object, a Discord user in that context value, and I got at that point I was like that ended up being
yeah,
too out of scope.
yeah,
But yeah, it was definitely with the testing. I would say definitely it's hard to really answer that because I feel like everything was a stumble. It was the first
sure.
time I learned the language, right? So like everything was like, okay, well, I'm gonna take like an hour and try to fix this.
Okay, I guess on that note, the difference. So the difference between Java and Python, in your own words, like what you mentioned how much you enjoyed sort of not having to type public static void and all those sorts of things. I thought when I was looking at the code that you wrote, um, as I'm glancing through it, what how would you expect to write something similar in Java? Could you, like, would you have thought about it in a different way? How would you have maybe started if this was a Java project?
Well, I've created a Discord bot in Java before. I forgot,
Okay.
like it was like the JPA API or something.
Okay.
Um, it, I'll be honest with you, I was so confused with that project that I don't know if I can actually answer that question.
That's fine.
Um,
Just
it
from a
was just
language
so
perspective,
easy. Yeah, from a
Okay.
language
Yeah.
perspective, it would be more it'd be a lot more syntaxy and stuff, but yeah, um
I noticed that you also didn't necessarily, like, I saw a couple objects in the Python code, but you weren't forced into object-oriented programming in every single facet.
and you're like partially answering my question there now that you bring that up. Everything would have been object oriented. And I mean, I was writing a Spring Boot app at the same time. And that
Ah.
was very like, you have your controllers, your MVC model, and, your beans, and everything
Mhm,
was like an object. It was like a Twitter like application, and it had, like different logs and stuff.
mhm,
Where in Python, I very much did not use OOP like method. And you know what? I find that's why I like learning Java first is
mhm.
I don't think I could have learned OOP principles in Python like Java, because Java requires it. Java will
Oh, yeah.
yell at you if you don't do it. So
Fair enough. Yeah, no, I see your point. And yeah, I think uh, I like hearing, the perspective from, especially from someone like yourself, someone who says that, what, I've never written any Python before. And so getting your perspective is so important for a lot of the others who are just as curious about, well, is this for me? Like, there are certain people who say, what, I learned C# is Python for me. Well, you tried and, well, you presented on it. So, that doesn't mean you hate it, I hope. So,
oh, I really like Python. I struggle going back to Java after writing in Python for a
oh,
little bit.
interesting.
I'm like, and I'm a little rusty here because I was in that job search and I was doing all my like data structure or algorithm prep in Java. So now I'm like flipping that switch back to Python. But no, I really enjoy Python. I think it's very versatile, and yeah, so definitely a beginner project. But I'm really happy I was able to present here. Now I see Abram here. He
That's
asked,
right.
"Is it okay if I move on to the next question?"
Of course, I was going to say that's going to be the last question, and then I'll definitely open the floor up for Abram to present.
Okay, async in a new language. You know what? It was a little bit difficult. Most of the async that I have experience with in Java is actually in like writing in Android Studio and using like async tasks. Um, I knew the concept in Python, but the syntax was a little bit different. I found also testing the async methods. A lot of my problems was writing unit tests for anything because I'm so new to it. It's something I'm still trying to wrap my head around. Um, but I find Python was a lot easier. Like the async await, like it just ended up being a lot easier than than Java for sure.
What I'm hearing is that like async await as a concept was
Mhm.
easier to sort of like, chew on and sort of pick up in a Python context than maybe like in the other experiences like async task. I think that was in there since like the early days of Android development, but that's an object, and I
Mhm.
guess your calling methods on an instance of an object just to figure out if the task is done, and like all those sorts of things. And um, I think when people look at async in Python, it's just a keyword a lot of the times,
Yeah.
to a function call of some sort.
Yeah. Yeah. A lot
Right
less
on.
intimidating. It just made a little bit more sense. It
Mhm.
was a lot. I feel like Java in general is just very syntaxy and intimidating. But
Mhm.
yeah,
Cool. Okay. Unfortunately, Kaitlyn, I think we're going to have to leave it here. But again, thank you
it works.
once again for your presentation on Pear. I thought that was a really awesome name. I'm glad you didn't let or I didn't remember the name when you talked to me about
It
it.
was a cool Python project.
Awesome.
Thank you. Yeah, no,
Thanks,
it was great.
Kaitlyn.
Thank you.
Cheers. Alrighty.
Yeah.
Let's ask Abram to get up onto the stage here.
All right. So what I wanted to talk about today is I had a problem where I wanted to shuffle some videos or sounds, it doesn't matter, but I wanted to watch a new video every day and I didn't want it repeating recently played videos. So if I had 7 videos, basically I should only see them once a week if that's my period of watching them. So I wanted like a playlist that worked that way, but I also wanted a playlist where I didn't need to save any information. A playlist where it was memoryless. It didn't need disks. It was kind of like a functional playlist. It would auto generate. And to do this, I had to take advantage of some aspects of random number generation. So today, what I'm going to talk about is briefly random numbers, linear congruential generators, shuffling, Fisher-Yates shuffle, and maintaining a shuffle. So we'll first get in the random numbers. If you have any questions, ask them in the chat. I'll stop every once a little while and check. Other than that, so when we talk about random numbers, usually what people are talking about is numbers that are pulled from either a set of numbers or a distribution of numbers. They're supposed to be selected in a way that either matches a known distribution, like a normal distribution or a uniform distribution, and you generally expect them to be not repeating and to have properties of randomness that we expect. Oftentimes, these random number generators are meant to simulate things that we'd observe in real life, like coin flips, dice, emissions of radioactive isotopes, those kinds of things. You might not do the radioactive one often, but nonetheless. So the problem is we have digital computers. Digital computers are great at determinism, and that's pretty well why we use them. And that means generating something randomly becomes kind of difficult. So let's first look at how you generate random numbers in Python. So I'm going to import the random module, and I'm going to import a counter module from collections. I'm going to have a function that just prints out multiple calls to the function f, and then it prints out like the first 100 of them and prints out a counter. So I'll make my Dilbert random. So this is a function and it generates a random number, and the number is always 4. Okay. This function is called not random. It uses the random module and it chooses a random integer between 0 and 0 inclusive. So this one is randomly selecting a number between 0 and 0. This one is randomish. It uses randint in random, and it'll choose a number that'll be either 0 or 1. And then if we want a floating point number, we can just call random.random. Okay, so that's fun. So let's just click that. Let's do that. Let's run it. And what do we got? So for my random generator, you can see it's doing the right thing. It's generating all 4s, and it counted 10 4s. or not random, it's a bunch of zeros, counted, 10 zeros. And then for this looks random, it's a split between 6 and 4. If I run this again, we'll see that we got 5, 5. I run it again. I got 8, 2. Ooh, we got lucky. 8, 2 is relatively uncommon. So we have 8 ones and 2 zeros. This is still random, and this is what we expect. And you can see that the floating point numbers are pretty all around. So if you do want random numbers in Python, Python provides good quality numbers that are seeded with the system timer using the Mercian twister algorithm, and they work pretty well. So random, random int. This is an inclusive range. They work pretty good. How does Python or other systems do this? Well, they usually use a random number generator. Now, Python does not use a linear congruential generator, but lots of other programming systems do. These are very cheap random number generators that don't require a lot of computation to make a number. It's stateful in the sense that you feed it its old version. So whenever you hear someone talking about a random seed, usually it means the initial conditions of the random number generator. So to make a random number, usually what you do is you take your old random number and you multiply it by a constant. So the user does not provide this. You add to it an increment, and the user does not supply this. And you then modulate it via a modulus. So you apply a modulus operation that's remainder after integer division, and you choose a modulus. I think increment and modulus are supposed to be relatively prime, which means that they don't divide each other. It doesn't mean they actually have to be prime. Okay, so this is the algorithm. How do we do it in Python? Well, we set ourselves our seed value. I'm just setting it to 1. We get a multiplier, and we got an increment. These ones, while they are very close together, they are pretty unrelated to each other in terms of divisors. And then here is our modulus, which is basically 65536. Okay. And so we modulate by that, and we'll get a new random value. So I'll click this, and you see I got 149. I'll click it again, 149. Why am I getting the same number? Well, because this is pretty well like a pure function. Nothing is random in here. If I want a different number, I'm going to have to change the seed. If I change it to 2, I get that. If I change it to 51, I get this big number. If I change it to 128, I got about 10K. Interesting. Change it back to 1. Okay. What these random number generators do is they recursively call this equation. So this is the old version, this is a new version. So what it does allow us to do is it allows us to produce a sequence of numbers that look random. So I'll click play, and it generated them. If I click play again on both of these, it takes a really long time for no good reason, and it generates the same sequence. If I just run this section again, note that there's state being held in these values. If I just run this section again, it won't start with 149. It'll actually carry on and produce more random values. Okay, so this is basically the old way that people, well, C++11 still does, produce random numbers. So this is a linear congruential generator, and it's really cheap. The most expensive operation is probably the modulus, and then the multiplication is pretty expensive. I want to check if you got questions yet. Oh, good. Someone found the Dilbert. That one's very appropriate. 444. Okay, you should see my screen again. Now, let's take a look at the quality of these random numbers. So one way you can investigate random numbers is you can look at the histogram. And the histogram shows us that certain proportion of the numbers fit into each one of these 50 bars. Okay, so I'm just using PyPlot. I'm telling it to make a histogram. I give it my random numbers, and it's making 50 bars. And we can see that they're pretty consistent. There's a couple bars peaking up here, but they're pretty even, right? If I change the seed, it should be pretty similar. So let's just do like favorite number, and we'll plot it again. And you can see the bars are different, but you know, it's not super interesting. All right, so we shall do that. Now let's do the same thing with Python's random. So this is when I ran an old version of it. Let's run a new version of it. Okay, and I should be able to run it again, and it should come up with a different thing. So there's a low peak here about 0.4. Let's run it again. So what I'm trying to demonstrate is that Python's random produces random numbers, and they're a sequence of random numbers, and you're in a different part of the sequence. Every call to rand or random changes state, okay? And so that means every following number will be related via a mathematical relationship to the previous one, but it's supposed to be in such a way that it's hard to figure out, okay? So you can see that this is very jaggy, right? And you're like, doesn't that mean that Python kind of stinks for randomness? No, it doesn't. If we increase the number of or we increase the number of samples of random numbers, which is quite a bit, and it's kind of taxing on Python, you can see that it evens out pretty good. Python's random number generator is pretty good quality. So let's check how good it is for zeros and ones. It's pretty well equal proportion 0 and 1. That's kind of what we expect. Even if we increase the range, it's pretty hard to tell if there's any difference between them. If we just ask for numbers between 1 and 10, we get the same kind of thing. We basically get 10 bars, they're pretty well equal. If we ask for a larger range of integers from 0 to say 65535, pretty good. But we're really just eyeballing it. This is called guru testing, and this gives you a false sense of security, making you think that it works. Now, this code is stolen off of Stuart Gordon Reed, who stole it off of NIST, and they stole it off of, I think, Newth and others. And what it is it's a spectral test. And really what it is it's checking for signals of different frequencies in the random number sequence, and it really only wants to look at bits like 0 and 1, and it calculates basically a p-value based upon error. And if that p-value is less than 0.05, that usually indicates that the numbers from your generator appear in ways where they appear in certain frequency bands, and that implies that your random number generator is somewhat predictable and not great. So let's go and run it for Python's random integers. Okay, we got a 0.23. That's fine. That's above 0.05. I'll run it again because it's random. We got a 3.2. Okay, let's try it on an array of all zeros, and it gives me 0. Let's try it on an array of all ones. It gives me 1 or 0. So both of these aren't good randoms. And then let's do it for 0, 1, 0, 1, 0, 1. Okay. Cool. So let's go check the last bits of our generator, and it did not like them. It did not, in terms of even and odd, it is finding that even and odd values are predictable with the current setup of our linear congruent generator. So that kind of stinks. So one of the problems is with LCGs is the initial conditions. Your seed can matter, your multiplier matters, your increment matters, and your modulus matters. So why don't we go and test a couple more? Okay, so here's the LCG function, and it's going to generate 10,000 random numbers in a sequence. And this allows me to pull whatever bit I want out of it. So we're going to look at the first bit, the even odd bit, using Turbo Pascal's linear congruential generator. we have a p-value here, and it's super tiny, which means it's garbage. It's not a good setup. Let's move on to C, C++11's min standard rand. And we'll do it for every bit. And we can see that for the first bit, it's pretty close, pretty low p-value, but everything else other than that bit has pretty good p-values. We can try to run it again, but it's going to give us the same numbers because it's the same seed. I can give it a bigger number, and it'll give us different numbers. Okay, so that seed worked out a little bit better, although that's a failure. But that's still better than what we saw before. Let's look at Microsoft Visual C parameters. And you can see that the first 16 bits or so are pretty bad. Then let's do new 64-bit mmix. And the first 16 bits aren't great, but the other ones are fine. And then let's look at Java. Okay, so Java's kind of stink right there, but then they're okay. So I was just showing you different settings. You can get these yourself off Wikipedia if you want. I was just showing you like different settings. They're all down here. They have different qualities and there's different ways of doing them. So just watch out. And that's basically a simple way to make random numbers. All right, so no questions yet, but here's the Wikipedia if you need it. All right. So, moral of the story, randomness is fraught with difficulty and tough math. Maybe you should just trust the random module in Python to a certain extent. If you use it for cryptographic stuff, you should use a different module, trust me. So let's get down to shuffling, okay? I like shuffling. Shuffling is what we do when we play cards, where we try to take a deck of cards, we try to shuffle them such that the cards are in a different order than when we receive them. So let's start with a list, and this list will be the numbers 0 to 9, okay? And we can sort that list, and it should produce the same value. What I saw a lot in Ruby and other languages is people would use random as a key to randomize the list. So here, by saying that the key is a random number, we can basically put the list in random order. So let's see if I can run this again. So you can see that it runs. So should I trust this? Was that maybe I was just lucky this time? Well, let's run it 100,000 times and then look at the distribution. So we ran 100,000 times. We're looking at distribution. And now let's look at the spectrum of the first bit. Okay, so it was fine with that one. Let's see if it likes the next one. Yeah, so it thinks it's relatively random. Probably what's happening is when I ask Python to do a sort, it does this key mapping once, like it makes like a dictionary temporarily, such that basically we've got tuples of random numbers. In general, it's not a great way to use sort to shuffle. But if you are going to use a sort that you don't know to shuffle, what I do recommend is you use the zip method. So with the zip method, what you do is you do something like this. I guess I should have added an extra thing. With the zip method, you do, let's go list. What you do is for every element in your list, you generate a random number and you put that in a tuple. You sort the list based upon the initial first random number, and that sorted list will now be a permutation of your original list, which will be basically shuffling. So if we do this using zip and unzip, we can see that we get relatively good quality results. Unfortunately, there's a cost here. The cost is that these are O log n, n log n at best, and they typically need ON memory. So this is actually a waste of time for shuffling. So there are more efficient ways to shuffle. But before I get into that, I will just check to see if anyone's got anything. For secret cryptography uses, yes, module secrets. Good. Okay, So let's think about efficient shuffling, and not if I can spell efficient. So let's do shuffling without sorting. Consider how we might shuffle. So we might have our list, and what we might do is we might choose an element at random from that list, pick it out, and put it at the end of our new list. And then we repeat that. So we keep pulling an element out of the one list and putting in the other one. This can be a little inefficient because it means that we are reducing the size of one list, we're manipulating and mutating it, and then we're growing the size of another list. So we have allocation issues there, but it would give us a random shuffle. We can do this a little easier, right? We can do it a little bit more efficiently if we stay within the same list. So if we allow our list to be mutated, what we could do is we could say for each element in the list, I'm going to swap it with another element in the list. This means that any element will have a chance to be swapped, okay? So what we should do, though, is we should only swap it with elements ahead of that current element. Either that current element itself should swap, or it should only swap ahead, such that the old swaps are kept, okay? So element 0 can be, in that case, element 0 could be swapped with any location. Element 1 can be swapped, could already be swapped with element 0 or any element after it. Element 2 could be swapped with element 0, 1 already, or anything after it, itself or after. So what this does is it basically says that if I run this every single time, the elements have a chance of actually swapping with any location whatsoever. There's also a chance that they swap twice, where I swap the element in and then I swap it back, but it's not going to be swapped back to exactly the same spot, okay? And what this produces is a nice little bias, and this is called the Fisher-Yates shuffle, and it works really well, and it works in linear time. That is, we visit each element once, okay? So what's the code for the Fisher-Yates shuffle? Well, for I in the range of the length of the list -1, so we're not going to the end of the list, we're going to the penultimate end, we'll generate a random number, and that number will be from I to the end of the list. So don't generate a number before the current element, but generate a random number from this current element to the last element of the list. And then we use Python's little tuple syntax and we do a swap, okay? And this is the Fisher-Yates shuffle. It works really well. It's linear. It's ON. Works pretty good. So let's go run Fisher-Yates now. And I can run it again. It shuffles our list. So you're like, okay, it shuffled. I don't trust it. Good. You shouldn't trust anything I say whatsoever. You should actually ask for tests and, evaluation. So what we're going to do is for every index, we're going to get the distribution. I'm going to show you the distribution of every index, or at least the last one. But I'm going to print the spectrum of the distribution of things at that index. So I'm going to print the spectral test for index 0, index 1, index 2, like they're a sequence. So this is basically a random test. So we go and run it, and all of these spectral tests are passing. So that's good. And you can see that the distribution for indice, this will be for the last indice, that it's just as likely to have something from bin 0 than it is from bin 9. So it's a even distribution across the board, so it's shuffling pretty well. Now, you might have been wondering, which I actually want to go and check. Oh, no one cared. Okay, good. You might have been wondering, why do we swap at the current element and the future rather than elements in the past? Well, I could speak a bunch of math at you, or I could just show you. Oh, wait, I'm out of order. First off, Fisher-Yates, you don't need to type it in because it's already built into the random module. You can call shuffle. So I'll do shuffle in place. Unfortunately, it doesn't return a value, so I have to wrap it up here. And I'll show you what shuffling in place does. And you'll see that it's, good quality results other than that one, and the same kind of distribution. Okay, so fundamentally, you can forget about Fisher-Yates forever now. You can just call random.shuffle, and that will work for you. Okay, now back to Fisher-Yates. Why is it that we have that the proper Fisher-Yates shuffle as I right here and not 0? Why can't we shuffle the whole array? Well, let's run the bad Fisher-Yates and let's do our evaluation the same way. But we'll print a distribution for every bin, for every element. Okay, so I evaluate bad Fisher-Yates, and now we go and do this. So we generate the distribution, we show the distribution, and we print the spectral test. So the first one, it's not exactly even, but it's not that bad yet. Spectral test doesn't care. This one, slightly uneven, but spectral test is okay with it. This one, uneven, uneven. They're passing the spectral test, which is interesting. This last one looks good, but then look at this one. The last element, it really fails the spectral test and it has incredible bias, right? Most of the time, the last element is still there. That's weird. Okay, so some of the indices are not very random at all. So that is a quick empirical demonstration that you should really set this back to I. So I'm going to switch to 0 with I. I'm going to evaluate this again. You're going to see the magic of the Fisher-Yates shuffle. See, it's all nice and even Steven. Okay. So what do we learn about Fisher-Yates shuffle and what's a bad Fisher-Yates shuffle? And that random.shuffle is perfectly fine other than it not returning a value, and it mutates the original array. Okay. So let me just check if there's any questions yet. Nope. Okay, let's get back to the brass tacks. What was I trying to do? I wanted a playlist generator. You should see my screen. I wanted to watch a different video each day. I wanted the order to be random. I don't want it to repeat one video a lot. I want each video to play once per time unit, like a week. I don't want to see the same video twice in a row in the same week. Starts or ends are okay. Given video 1, 2, 3, 4, 5, I don't want to see a sequence of 1, 2, 1, 3, 1, 4, 5, 1. I don't want a lot of ones in there. And I don't want to remember anything. I don't want to have to save anything to disk. I don't want anything like that. So the nice thing is that shuffling guarantees that for a list that one video only appears once. But how can I shuffle repeatedly? I can shuffle for my current week, but how do I shuffle for the next week and the following week? And how do I keep that shuffle consistent? So what I want is, given the various videos that I want to watch, like Chungus, Friday, Dogs, Cats, Python tutorial, math video, and Rickroll, I want one week to look like this, and I want the other week to look like that. Okay. So I want basically 2 shuffled weeks, but I want each week to be set up that way. Interestingly enough, both of these ones, these Rickrolls, started with it, but they have different orders. Okay. So what I really need is for all the days in the week to basically have the same shuffle. And how do I get them to have the same shuffle? So if we look at stateful randomness, right, using rand, using the random module, what we'll find is that we can get a random shuffle, right? But if we set the initial conditions of the random number generator, we can actually get it producing deterministic results. So if I just set the seed to 10 arbitrarily, it will produce the same result twice. Okay. So all the random calls after this call will be seeded by 10, and all the random calls after this will be seeded by 10. So if I click run, what you see is that the stateless randomness ones with the same initial conditions are the same lists. Okay. So by setting the same seed and calling random in exactly the same order and consuming random values in the same sequence, I get the same sequence. So if two things are using the same generator, but initialized the same way, we will get the same sequence. Okay? Check. No questions. Fine. All right. So how do we get so to get the same shuffle, I need the same seed. So what could we use as seeds? Well, I know I'm dealing with days. I know I'm dealing with weeks. Those might be a good input. Or I could take that day and that week and I could, I don't know, hash it or something. It doesn't really matter. But the fact is I need something that produces a number. So, and it needs to be related to time. So let's make a function called days since epoch, which is really the number of days since January 1st, 1970, the start of Unix time. And I'll evaluate it and divide it by 365. And you'll notice that it's many years ago. So it was a while ago. Okay, so now I have days since epoch. So let's run this for about 2 weeks from now. So I'll generate dates for October from now for about 2 weeks. Okay, so now I get days since epoch. So basically 52 years. Okay, but I want them for the same week. So what I can do is I can actually integer divide them, right, by the number of videos I have. So if I run this, it says 2753, 2753, 2754. That repeats for 7 times, then goes to 2755. That's cool, but I want this week to start now. I don't want, 2 videos from my last shuffle. I want the shuffle to begin now. So what I can do is I can add an offset of 2. So using date times time delta, I can give it a constant day, 2 days, can run it, and boom. Now my list, I basically have 2 weeks, and I can use these as the seed. And this means that anytime I ask a question, a random question on these days, I'll get the same random sequences. Now that we have a name for the week, we can generate shuffles for that week. So I'm going to make some helper functions. The day seed, what this is going to do is it's just going to return the epoch and maybe with an offset. If I don't give it any values, I'll initialize it from now. So it's going to return the days since the epoch. The week seed is the same thing, but just divided by n, which will probably be 7. And week seed and day, it does the same thing. It calls day seed, and then it calculates the week. So it returns the week, the day, and the day minus the week. So this will be like the remainder. Okay. So now we can go check out the week seed, produce the same value. And then let's look here. So for 30 days, generate the week seed based on the videos, generate a day. So keep generating days in the future, seed the random number generator with that seed, and print out the Fisher-Yates shuffle or a random shuffle of those videos. Okay, so for this day, I have these videos, and then it switches off to these math videos, then starts with cats, then goes cats and dogs again. Friday ends. That's kind of interesting. That's 7 videos per day, but I only want 1 per day. How do we deal with that? Well, we basically calculate our days in that list. So day 1, day 2, day 3, day 4, day 5, day 6, day 7. That's really what we want. We'll calculate the index in that list and we'll print that out instead. Okay, so we get our seed, we get our day seed, we get our number of days, we set the random number generator and we ask it to generate. Okay, so now I've got myself a schedule of videos to watch with very little repeats. Okay. Now I can put this all in one shebang, video of the day. And now I can show you the video of today, tomorrow, and then the next week. So that's cool. All right. That one's redundant. So now I have a memoryless video function, and I don't need to maintain state. Let's answer another question. Is it safe So let's look at the distribution of the video numbers, and let's look at the spectral test. And then I want to count doubles. So I want to basically count whether or not a video appears twice in a row. Now with shuffling and concatenating shuffles, there's a chance of this happening if I ended on dog and started on dog for the next week. So that can happen. So let's go and run this. Let's first look at the quality of the results. We can see that all the videos occur equal number of times. It's relatively equal. And the bits of the shuffle indices all pass the spectral test, so we're good. And then it found 22 doubles, and that was a probability 0.02. Now, I also did sampling to show you empirically what happens when you calculate these doubles. And if we just sampled rather than shuffled, we would have a probability of 0.13, basically 1 out of 7, that it was chosen at random. So I've actually improved the fact that I don't have hardly any doubles, right? So that's pretty awesome. Okay. So if you want to put it all together, really what you needed is days since epoch, your day and week seed, something to calculate videos of days, and then this. So you could just put it all in a little shell script and it could print it out. You could change some parameters off the command line, anything like that. So in conclusion, you can play with random seeds to get determinism and randomness at the same time. Random numbers on computers are deterministic. LCGs are simple and brittle and strongly reliant on their initial conditions and constants. Shuffling can be done in constant time. Using data as a seed can get you the same response for the same time period. And by setting the seed, you're doing it globally, and you're going to basically make your stuff probably less random if other things are calling random. So watch out for that. Okay. So now let's just go to questions because that was pretty fast. And there was a lot to talk about, but that's fine. All right.
Alrighty, well, in
So Q&A mode.
Yeah, I'll go into Q&A mode. I don't see any. Well, in lieu of questions, I would like to give a round of applause for Abram for his deep dive into, well, deeper dive than I've done into the random and shuffling in Python in a while. I guess it was not much of a question, but I think I had the feeling when I was learning Python that when I discovered random.seed, that when I called it for the first time, I thought I broke my computer because I was seeing the same output. And that's when I learned that determinism, like there's the concept of determinism. And I just wanted to bring that like beginner's journey into this because it turns out that random is a lot more complicated than I gave it credit.
Well, I had a problem a while ago. I was using awk, and I was using awk to sample things from a stream, and it used randomness in awk. And if I ran that script in the same, I guess I'll stop sharing. If I ran the script in the same second, it produced the same results. I was like, what? So I go and look, and they seeded their random number generator based upon the current seconds since the Unix epoch, basically time. And that meant that anytime my script ran in that second, it produced the same output. I was so irritated by that. So my solution was to have bash give random numbers as the seed to awk and invoke awk with bash induced random values, which did not suffer the same problem. But it was still very awkward. I didn't enjoy that. And that's why I think it's kind of important to understand seeding, as well as, the fact that these numbers on your computer, they're not magic random numbers. Actually, your magic true random numbers are really expensive numbers to basically calculate from, statistics on the computer. The normal numbers you deal with, they're, sequences, known sequences. Many of them actually exist in the online integer sequence encyclopedia.
Oh wow.
Yeah.
So
So
this okay.
yeah, big failure ones exist there. Yeah.
Wild, because I again, going back to what I was doing on my computer, the last point you made, when you call random.seed, you will affect the behavior beyond maybe even just that like I found that I think it affected a couple like open shell sessions that I even had at the time. So for that moment, it was kind of initial panic, because I was like, why do I keep seeing the same like values over and over again? That, for a naive person like myself learning it at the time, did not seem random. But it opened up this whole truth that, well, usually it's a sequence of numbers that's like, it's either naively speaking, it's either a pre-generated list of numbers provided for you already, or the sequence is deterministic based on that like initial seed value. And that was, yeah, that both scared me and also was like, okay, there is so much respect for all the things you just take for granted by calling random.
I was trying to get a leg up on an online game that I knew was using Turbo Pascal. So I had to go dig up the source code for the Turbo Pascal random number generator to see if it had any of these weaknesses. But I think the one used at the time had been pretty mathematically verified and was pretty safe. But you can get cases like some of the generators I was showing where they have unsafe systems, and you can basically generate a lot of random sequences and try to figure out the current state of the random number generator. So if you know the state of a current random number generator, you basically can predict its future.
Oh, we have a question, and it's from
Ooh.
Carson. What's your opinion about p-value for some of the algorithms being used, given the controversy around fixating on, I guess, the fixation on
Yeah.
p-values?
Yeah, so p-values, what I like about them is how often I can get them to fail. So a lot of those tests I showed, if I would have ran that test 20 times, I would have gotten 20 times where it looked like it was working. I would have gotten one failure probably if I set my alpha at 0.05. So uh, they are a little sneaky, and you can, if you just, base your decision off of one, you can really lose out. So a lot of data science and a lot of data mining, they all use like pretty high p-value threshold 0.05, which allows like a 1 in 20 kind of chance of failure. And so they can produce spurious results. Um, Also, another thing they can do is they can run lots and lots of tests and then not correct their p-values against these spurious results. So the idea is, if I run 20 tests on like the same data set or same generator, my alpha should not be 0.05 anymore. Conservatively, I should probably divide it by 20, and that should be my level of failure that I'm looking for. Not necessarily in this test, but in other tests, if I'm trying to say something past a test, like it's different. So p-values are okay. They have their place, but most people don't really know what they mean. So maybe something that's good to use, especially in comparisons, like if you're doing tests that are comparisons, is to actually produce like a 95% confidence interval of the difference, such that you can know what the differences are in that 95% of the time range. And then that can be a better alternative. But p-values are kind of here to stay, but p-value abuse is definitely rampant. Then Carson's got another one, maybe a bit off topic, but if you can briefly elaborate on the secrets package for crypto. Yeah, I don't know that package.
Like, oh, I think he meant the secrets module, and I guess if you can't answer that, like, why would we? Why does Python recommend, like, for the beginners, I guess, why would they recommend that they don't use the random module and that they use the
Oh, I
secrets
see.
module
Okay,
instead?
I just read the man page. Um, on Linux, you've got they have urandom, which is like a garbage random generator, kind of like a LCG. Use urandom when like you're really desperate for random numbers at the command line or something like that. It's fine. It's just like running Python. Uh, dev random on Linux, it's attached to an entropy pool. So all these events that you're doing, all the network and all the typing and everything like that, both randoms are good randoms. Okay, so Andrew says that I'm totally wrong, and that dev random is
that
totally
true?
awesome. But that's
I
fine.
don't know.
But,
I don't want to turn this into an epic debate
let's
war.
just talk
but
about dev random here. Dev random here typically relies on other sources of entropy, other sources of information, events on the computer, such that they're less predictable and they feed into a entropy pool, and with multiplication, all this fun stuff, you can get pretty good quality random numbers out of it. So I'm pretty sure that the secrets package is trying to give you good quality random numbers, probably from your operating system. But that's just because I read the MEM page very briefly.
Yeah, I want to believe that, and I do take the Python maintainers for trying to aspire to make like these confusions not part of the language, but despite that, they still have the big red banner. So maybe they do both random supply good randoms now, but something is still telling the Python document maintainers to keep the big red. It is round.
Yeah. But probably the secrets module on a Linux machine is going to pull from dev random, I assume. Yeah.
Got it.
But people run into the random urandom problem a lot when they install SSH on a cloud machine, and then SSH takes forever generating a private key for the host because it doesn't have enough sources of entropy. Yeah.
Cool beans. Okay. Well, I think that's all the time that I would like to. Well, yeah, I'm looking at the video counter. It says an hour and a half. So I think you've answered. Usually try to keep it to about 3 questions. So one final round of applause here for Abram. I accidentally
Thank you very
stumbled
much.
upon thinking I broke my computer with random.seed, but here we are learning why. That is part of it. So, all right, I'm going to take
All
this
right.
last
Thanks, Aaron.
opportunity. Thank you, Abram. I'm just going to take the last opportunity here to share the announcement for our next meetup. So, our next meetup is on November 8th. And I'm going to put in brackets pending talks because at this point, there's a constant chicken and egg problem with local meetups. So we are always looking for presenters, and I am not going to force anyone to necessarily present next month. But if you have an idea and are looking for some encouragement or for some direction or even a quick rehearsal or tips and tricks on how to present publicly, I'm here to help. We're here to help. And all we ask is that your talk just has to do with Python in some way. I only listed out 3 names in here, but basically, if you're fine, I just want to keep it simple for the viewers. If you message myself, my name is Aaron. Should have started with that at the beginning of the meetup. It's okay. I'm just a little rusty. And then, of course, we had Abram present the second presentation, and Carson, fellow PyYYC organizer, was asking some questions about p-values just now. So we also are in the Meetup EdmontonPy channel on Dev Edmonton Slack. So with that, once I stop sharing screen, if you are wrapping up your day here, I just like to say thank you with us here. And this floor will be open for a little bit to kind of ask questions, mingle with amongst yourselves. But again, you don't need to overstay your own welcome. So, all right, with that, again, thanks everyone for participating in our October meetup, and I hope to see you soon. Cheers.